Elements are defined by how many protons are in the nucleus. However, we can have different numbers of neutrons in there as well, which we call isotopes. Now, certain isotopes are less stable than other ones, and they will eventually turn into something else. We don't know when a particular atom is going to decay into something else. However, we can measure the statistics of the decay process. For example, I like to play a game in my classes where students have to flip a coin. Now, if they keep getting heads over and over again, they win. But as soon as they flip a tail, they have to sit down. They're out of the game. For each round, we don't know who's going to get tails, just that roughly half the classes are going to do it. So if you walked in my class while we're playing the game and saw how many people were still standing up, you could pretty accurately guess which round we were on. The same is true of radioactive isotopes. Carbon-14, for example, is an unstable isotope of carbon. But if we waited an infinite amount of time, eventually all of the carbon-14 would turn into nitrogen and just leave the system, leaving behind a purely carbon-12 sample. Now again, for any given second, we don't know which atom is going to decay, but we do know statistically that after 5,700 years, half of the carbon-14 is going to leave the system. Using that fact, if we know how much carbon-14 is left, we can calculate how old a sample is. Famously, scientists used carbon-14 dating to determine how authentic the Shroud of Turin was. By measuring how much of carbon-14 was left in their sample of fabric, they were able to determine that that sample was only 700 years old, much less than the 2,000 that you would expect for an authentic piece of fabric. Thanks for watching.